So today we're going to talk about exponents. Now, we had talked about exponents in the throwdown weeks. Okay, we went through all the rules, we went through simplifying them. So today is just going to be a review. Okay, if you have any questions, you do have these in your notes that you took from when we did a unit on exponents. So integer, we're on page 24. You have worked with positive exponents and exponents of 0 in previous grades. When working with negative exponents, write the reciprocal of the expression with a positive exponent. So if you have a negative, you're just going to write the reciprocal. So you're just going to bring it down to the denominator, and then the exponent becomes positive. Okay, when we're in an exponent, this tells you how many factors of 5 you have. We have 3 factors of 5. So I have 5 times 5 times 5, which is 125. Properties of integer exponents. In order to perform operations with exponential numbers, there are several properties to learn. These are sometimes referred to as the laws of exponents. Okay. To multiply numbers with the same base, okay, your base is right here, you're going to just add the exponents. Now you can't do it if the base is different, but if the base is the same letter or the same number, you can just add the exponents together. So if you look over here, my base is 5, they're both the same, so I'm just going to add my exponents together. Okay, 2 plus 4 is 6, so I have 5 to the 6th power. Okay. To divide, you're going to do the opposite of multiply, you're going to subtract. Again, your base has to be the same. So, look over here. I have 6 and 3. My base is the same. 6 minus 3 is 3, so I'm left with 5 to the 3rd. To raise a power to power, you're going to multiply it. Okay, so you see how this is a power raised to another power? AKA, you see parentheses, and right outside the parentheses you have an exponent. That means you're going to multiply these together. And the way that helps me remember is I distribute this inside the parentheses. So it's going to be n times n. Now these two are different because here you're multiplying. Here you have exponents. So I have 5, 3 to the 2nd. So you see parentheses. Okay, I'm going to multiply. 3 times 2 is 6. So I'm left with 5 to the 6th. And then this last rule, you don't have to know that one. Okay, working with negative bases. It is possible to have an exponential expression in which the base is a negative value. When working with negative bases, the use of grouping symbols is important. Considering the following question: is negative 2 to the 6th equal to parentheses negative 2 to 6? To answer this question, we will write out the expression in expanded form. Okay, so this is negative 2. So the first one's going to be negative, and then all the other ones I'm going to have 6 copies of 2, or 6 factors. And that's going to give me negative 64. But if I have parentheses, okay, this 6 applies to everything in the parentheses. So I'm going to have 6 factors of negative 2. I get a positive 64. So they are different, so really pay attention to your parentheses. Okay? Let's go do some practice problems. So let's write each expression to have one term with a positive exponent. We never want to have an answer with a negative exponent. So 5 to the 2nd times 5. And so if they don't have an exponent, there's an understood 1. So is my bases alike? Yes. Am I multiplying? Yes. So when I multiply two numbers, okay, 2 exponents, I'm going to actually add the exponents together. So 2 plus 1 is going to give me 3. Okay, let's look at 2. I'm dividing. Is my basis the same? Yes, so I'm going to subtract my exponents. So 8 minus 5 is going to give me 3. Now here, okay, do I have like bases? Yes. Add my exponents. 2 plus negative 2 is going to give me negative 4 to the 0. And anything to the 0 power is going to be what? 1. Over here, okay, I'm not combining anything. I'm not multiplying anything. But do I have a negative exponent? I do. So I have to do the reciprocal. So if it's on top, I'm going to bring it on bottom. If it's on bottom, I'm going to bring it on top. However, this is on top, so I have to move it to the bottom and then make the exponent positive. Okay? So down here, base is the same, multiplying, so I'm going to add my exponents. 6 plus 2 is going to give me 8. And this right here is supposed to be a negative. They left out the negative sign there. Down here, again, like bases. So I'm going to do 4 minus negative 2. So notice how this is a negative 2. Okay, pay close attention to your signs. A negative is going to be a positive. Okay, so 4 plus 2 is 6. Okay. 3 to the 0 times 3 to the 4th, where anything to the 0 power is going to give me 1. So I'm just left with 3 to the 4th. Okay. This one I have a power to a power, aka look at the parentheses. Anytime you see the parentheses, you have to distribute this 2 in. So 2 times negative 1 is going to give me 7 to the negative 2. I don't like exponents, negative exponents, so I need to do the reciprocal, so I bring it down. Okay, and then the last one. Again, I have a power to a power, so I am going to multiply. Negative 4 times negative 1 is going to give me a positive 4. And that's my answer. So go ahead and turn the page. Again, this is a very quick review, okay, but if you want more details on how to do this, it is in your notes. Okay, so now we're on page 25. So I want you to go ahead and pause the video and try doing these 5 on your own, and then come back for the solutions. Okay, welcome back. So she wrote the expression 5 to the 8 times 5 to the 5th. Which of the expressions shown is equivalent to the expression she wrote? What does equivalent mean? It means the same. Okay. So let's see if we can simplify this. Do I have like bases? I do. Am I multiplying? Yes. So I'm going to add my exponents. 8 plus 5 is going to give me 13. So my answer is going to be B. A bank vault contains 10 to the 4th pennies. Since 10 to the 2nd pennies are worth $1, an employee of the bank wrote the expression 10 to the 4th over 10 to the 2nd to represent the value in dollars of all the pennies in the vault. Then he simplified it as follows. So 10 to the 4th divided by 10 to the 2nd equals 10 to the 4th halves equals 10 to the 2nd equals 100. He concluded that the pennies in the vault have a value of $100. Which of these statements are correct? Okay. First of all, what did he do? Did he subtract the exponents? No, he did not. Okay, he divided. He said 4 divided by 2 is 2, so that's going to be my answer. Okay, when we divide exponents, what do we need to do? We need to subtract them. So he should have said 10, 4 minus 2 equals 2. So he got the same answer. However, okay, it's not always going to work out that way. You always need to, if you're dividing, you always need to subtract. Okay, so let's look at A. The employee made a mistake in his calculations but got the right value. Yes. He did make a mistake, but his overall answer was correct. So number 3 is a fun one. It says, is each of these a valid equation? Check yes or no for each equation. So we need to see if these are correct. So 7 to the negative 4th times 7 to the 6th equals 7 to the halves. Not the halves, second. So I'm multiplying, so let's see. Negative 4 plus 6 gives me what? Gives me 2. So is that my final answer? Yes. Let's check over here. Okay, I have a power to a power. You see these parentheses, so I'm going to multiply. 5 times negative 2 is going to give me 4 to the negative 10th. Is that 4 to the third? Nope. They did their calculations wrong. And what did they do here? They probably just added them. Okay. 214 to the 0 is 0. Nope. What is it supposed to be? 1. Look at D. -7. 6 to the -7th divided by 6 to the -9. I'm dividing, so I'm going to subtract. -7 minus -9. Two negatives make a positive. So, -7 plus 9 gives me a +2. That is correct. And then down here it's saying these two equal the same thing, and we know that is not true. Okay. Let's look at the next one. Consider the following expression. Which of the following is not equivalent to the expression below? So guess what we're going to have to do? We need to work out this one and see if it gives us this. Okay? So I have a power to a power. Now I have to distribute this power to each power inside the parentheses. So to do that, I multiply -5 times 2 is -10. And then -7 times 2 is going to give me 12 to the -14. Now remember, we don't like negative exponents. So to do it, we're going to need to bring this on top to make it positive, and then this on bottom to make it positive. So to make exponents positive, you do the reciprocal. Okay, so I'm just going to flip-flop these. Okay, now if we want to simplify even more, what do I need to do? Subtract the exponents. So 14 minus 10 is going to give me 12 to the 4th. Which of the following is not equivalent to the expression shown? Let's look at A. Okay. So it looks like what they did is they went ahead and flip-flopped them. Is that what we did? Yes, we read into after this, but we could easily come here and do it before we distribute that to it. Okay, so that is equivalent. So this is 12 to the 4th. Is that my final answer? Yes. That is equivalent. Okay, 12 to the -4th? No. That would not be equivalent because we know it's going to be a +4. And then let's look at this last one. It says select all the expressions that are equivalent to 6 to the -4th times 6 to the 6th. All that raised to the 3rd. First thing we need to do is distribute this power to each power inside the parentheses. And when I have a power to power, what am I going to do? Multiply them. So I'm going to have 6 to the -12th times 6 to the 9th. 6 to the 18th, excuse me. Okay, I'm multiplying now, so I'm going to add -12 plus 18. It's going to give me 6 to the 6th. Okay, so let's see which ones of these are equivalent to this. So what we can do is we can work out each one of these and see if it gives us the answer we want. So this is a power to power, so that's 6 to the 6th. Is that my answer? Yes. That's answer 1. Okay, here, if I move this to the top, I get 6 to the 12th and make the exponent positive, times 6 to the 18th. That does not give us 6 to the 6th. 6 to the 5th? Nope, that's not an answer. Okay, this is division. 18 minus 12 is going to give me 6 to the 6th. Yes. 6 to the -4th times 6 to the 18th. If I make this positive, it's going to look like this. And we can simplify that. 18 minus 4 is not 6 to the 6th. And then 6 to the 6th, yes. So my answer is A, D, and F. Okay, and that is all for today. For your homework, you're going to need to complete page 29 and 30. Okay. I believe you do not have to do 7, but you do need to do all the rest of them. If you have any questions, please email me, and I hope y'all have a good day.